Obtain the following primitives by performing a trigonometric substitution. Okay, so for the first one, we have the primitive of x squared plus 1 divided by the square root of x squared minus 1. Okay, so we've seen before that whenever we have the square root of x squared minus 1, one suggested change of variable is to use x equals the second of t. Now the x squared minus 1 is just the tangent squared, right? So the square root of this is going to be the square root of the tangent squared, sorry, so the tangent, right? And then dx is the derivative of the second, which is the second times the tangent, right? So then we have x squared plus 1 is the second squared plus 1 divided by the tangent times the second times the tangent. Tangent and tangent go away, so you have the primitive of the second cube of t plus the primitive of the second. The primitive of the second is the logarithm of the second plus the tangent plus c, and then the primitive of the second cube we have seen before in the previous exercise, so this is 1/2 of the second times the tangent plus 1/2 of this, so this is 3/2 of this, right? This is what you get. Another way to solve this is to use another change of variable, which is x is equal to the hyperbolic cosine of t, right? So now x squared minus 1 is the hyperbolic cosine minus 1, which is the hyperbolic sine squared, and dx is hyperbolic sine. So then you have hyperbolic cosine squared plus 1 divided by the hyperbolic sine times the hyperbolic sine dt. So this is just this, and then you have the primitive of the hyperbolic cosine squared plus t, right? And so in order to find the primitive of the hyperbolic cosine, we use the equality hyperbolic. So remember that hyperbolic cosine minus the hyperbolic sine is equal to 1, and then you have a similar formula for this hyperbolic cosine of 2t, right? So if you sum the two, you have a hyperbolic cosine squared equals 1 plus the hyperbolic cosine of 2t. Substituting here, we have this is the primitive, or 1/2 of the primitive of 1 plus the hyperbolic cosine of 2t dt, right? So this is t over 2 plus t 3 over 2 times t plus, and the hyperbolic cosine, the primitive of this is the hyperbolic sine, so this is 1 over 4 times the hyperbolic sine of 2t plus c. Okay, so we have two different values for this primitive. Let's say this is 1/2 of the second times the tangent plus 3/2 of the logarithm of the second plus the tangent plus c, or you have 1/4 of the sine, hyperbolic sine of 2t plus 3/2 of t plus c. Okay, so now how do we deal with this? Well, these t's are different, right? So we have to undo the change of variable. Here we had done that x was the second of t, right? And then the tangent was the square root of x squared minus 1. That was the tangent, right? So this is equal to 1/2 of x times the tangent, times the square root of x squared minus 1, and this is the logarithm of x plus the square root of x squared minus 1, right? Now here, in order to undo the change of variable, remember that this was x was the cosine and x squared minus 1 was the hyperbolic sine. In order to do this, we have to remember the formula. Hyperbolic sine is 2 times the hyperbolic sine of t times the hyperbolic cosine of t, right? Now here, so this is going to be, let me see, this is 1/2 of the sine, hyperbolic sine times the hyperbolic cosine. So this is 1/2 of x times the square root of x squared minus 1, right? Now this is 3/2 of t, which, and then t is the inverse of the hyperbolic cosine. And if you remember this, the inverse of the hyperbolic cosine is this. Okay, the logarithm of the square root of, sorry, of the absolute value of x plus the square root of x squared minus 1. Okay, so the two primitives are the same. Using the two different chains of variables, you get the same result. Okay, now part 2, you have x squared divided by x squared plus 1 to the 5 over 2. Okay, now remember that whenever we got the square root of 1 plus x squared, we used the tangent of t as a change of variable, right? Sorry, not x as the tangent of t. So 1 plus the tangent squared, this is just the second, or 1 over the cosine, right? And now we have dx is 1 plus the tangent, or 1 dt divided by the second, the cosine square, so the second squared dt, right? So if we substitute here, we have what? X squared, which is the tangent squared, dx is the second squared dt, and then we have x squared plus 1 to the 1/2, which is the second to the 5. So this is the second to the 5. Now second squared and second to the 5, you get second cube, right? And this is equal to the tangent times the cosine cube, right? Now the tangent is the sine squared divided by the cosine squared. Cosine squared divided by by cosine, you get cosine here. And now this is easy because this is the derivative of the sine cube of 3 divided by sine cube of t divided by 3, right? Okay, now let's see. You get the primitive of x squared divided by 1 minus x squared to the 3 over 2 dx. Now whenever we have 1 minus x squared, the proposition is to use x equals the sine, so this is equal to the cosine, and so dx is cosine of t dt, right? So now here we have the sine squared divided by the cosine cube times the cosine t dt. The cosine cube, you get cosine squared, so all of this is the tangent squared of t dt, and we know that this is the tangent squared plus 1 minus 1, so the tangent of t minus t. Now the tangent of t, if we want to undo the change of variable, is the sine divided by the cosine, x divided by the square root of 1 minus x, and the t is the arcsine of x plus c. This is the primitive that we were looking for. Okay, and now let's do part 4, the primitive of the x squared, the square root of 1 minus x squared. Again, x is the sine of t, the square root of 1 minus x squared is the cosine of t, dx is cosine of t dt, and so this is equal to cosine divided by the cosine, so dt divided by the sine square root of t. So this is the same as the primitive of the cosecant of t, which is minus the cotangent of t plus c. So the cotangent is the cosine divided by x. So this is minus the square root of 1 minus x squared divided by x plus c. This is the primitive that we want. Okay, so let me write it here. This is going to be equal to minus the square root of 1 minus x squared divided by x plus c. And let's do the final one. This is dx x squared, the square root of 9 minus x squared. So this is the same thing, right? But we have to write this thing different, right? So this is the square root of 9 minus x squared. You can take a common factor 9, so you have 9 times 1 minus x squared over 9, or in other words 3 times the square root of 1 minus, and let's say this is x divided by 3 squared, right? And so we can change our variable, say u is x divided by 3, or 3u is x. Okay, 3u is x, so 3 du is dx. So let's say this is equal to the primitive of 3 times du, right? Then divided by x squared, which is 9u, and then we have 9 minus, this is times 3, 1 minus u squared. 3 and 3 go away, so you have 1/9 of du divided by, this is squared, so u squared, square root of 1 minus u squared. But this is the same as this, so this is equal to minus the square root of 1 minus u squared divided by 9u plus c, and we just need to undo the change of variables. So this is 1 minus x over 3 squared divided by 3u. Now this, again, we can remember that this is equal to this divided by 3, right? So this is minus 1/3 of, so this is 3x, not 3u. 1/3 of 9 minus x squared divided by 3x, or in other words, this is minus this divided by 9x plus c. Okay, this is the primitive that we're looking for.